Hi everyone, so this is going to be our first example for those constant acceleration problems. So again, with our steps for how to solve a physics problem, I'm going to read through this once and then follow the steps from there. So we have a sports car is sitting at rest in a freeway entrance ramp. The driver sees a break in traffic and floors the car's accelerator so that the car accelerates at a constant 4.9 meters per second squared as it moves in a straight line onto the freeway. What distance does the car travel in reaching a freeway speed of 30 meters per second? So we would now want to decide what our coordinate system is. And what that means is that just where is x equals 0? We know that this car, right, we have a little car like this, and it's going to floor the accelerator and then speed onto the freeway. So I'm going to say that, okay, x equals 0 where that car starts, okay? And then the next step that we want to do is we want to draw a picture, which I already did. And also we want to say, okay, which direction is positive? Usually with problems like this, we just say that forward is positive, and that just makes it easy for us. Now I'm going to write down my given quantities. So I know that the sports car is sitting at rest in a freeway on entrance ramp. And when it says rest like this, I call this a hidden given because they're giving you something there, but they don't outright say what it is. And what that means is rest is just we're not moving. So that means that our initial velocity is going to be 0. So that's our hidden given there, that v initial is equal to 0 meters per second. It then says that the driver sees a break in traffic and floors the car's accelerator so that the car accelerates at a constant 4.9 meters per second squared. Now, it specifically says the car accelerates here. Sometimes they'll say, oh, it speeds up or it slows down. So you have to be really careful about what they're giving you there. Here, they're giving us acceleration. So I write A is equal to 4.9 meters per second squared. Now I have that as a positive 4.9 meters per second squared because I know that the acceleration is in the same direction as the velocity will be because we are speeding up, right? It's like that accelerator is pushing that car forward. So I call that a positive 4.9 meters per second squared. And then it says, what distance does the car travel in reaching a freeway speed of 30 meters per second? So we're going to reach a freeway speed of 30 meters per second, which means that my final velocity is going to be 30 meters per second. And then they're asking me what distance. So what they're asking for in terms of symbols is our distance, or in this case, it's our displacement, because distance and displacement are the same thing here because we're just traveling in a straight line in one direction. So that will be delta x in terms of symbols. And I like to write delta x equals question mark because that kind of reminds me what I'm actually solving for here. We have so many variables, and sometimes it's hard to remember what we're even solving for. And that's step 6 in our how to solve a physics problem is ask yourself, what am I solving for? Here I'm solving for distance or displacement, which is our delta x, our change in position. So the next thing I want to do is I want to pick the right equation. And you should have these ones written down right here. Here are my 4 equations that we get for our constant acceleration problems. And we can see here that first, right away, I can throw out 3 of these equations because I'm not given time in my problem. So since I'm not given time, I'm throwing out this equation, and this equation. And therefore, that's the only equation that I'm going to be using here. Now, another way to look at this is, okay, I can look at my givens and see that, okay, I'm given initial velocity, I'm given acceleration, I'm given final velocity, and I'm given, well, I'm not given it, but I'm looking for our displacement, our delta x. And so we can see that, okay, here I have initial velocity, I have acceleration, I have final velocity, oh, and I have that delta x, which is what I'm solving for. So that's the equation that I'm going to be using in this case. So I'm going to write that down. So I have my v final squared equals v initial squared plus 2 times acceleration times our delta x, our displacement. And then I'm going to solve this equation for the unknown variable. Now you can plug in your numbers here. That's totally fine. I like to solve first, and I also kind of plug in my 0, which this is a common occurrence here, is that, oh, your either initial velocity or your final velocity is going to be 0. And so here I know that the initial velocity is 0. So this whole term right here is going to be 0, and it's going to cancel out. Now the next step here, because I'm solving for delta x, I want to divide by 2 times the acceleration on both sides. And so here I get delta x is equal to v final squared divided by 2 times acceleration. And then now I can plug in my numbers. So I get my displacement or distance is equal to final velocity, which is 30 meters per second. I'm going to square that, divided by 2 times the acceleration, which is 4.9 meters per second squared. And so if I plug this into my calculator, I'm going to square 30, so 30 times 30, and then that ends up being 900. I'm going to then divide by, and then I open parentheses, 2 times 4.9, close parentheses. So I'm dividing by that whole thing on the bottom. And I end up getting that my displacement is 91.84 meters.